Alright, Titans, here we go. Episode 10, Section 13.3, trig functions of any angle. Our goals here are to find the 6 trig functions of any angle, and then to also find reference angles of any angle, which we'll do more in class tomorrow. But goal 1 is what we're hitting on right now. So let's go ahead and get after it here. Now, when we look at any angle, we have a general definition of trig functions here, and we have just that angle theta, okay? Let theta be an angle in standard position, and xy be any point except the origin, so except 0, 0, on the terminal side of theta. So remember when we drew in our angles, we had our initial side and our terminal side up here. Well, on the terminal side we can pick any point xy and we can find the 6 trig functions, okay? And we call, that length from the origin to our point, we call that r. So it actually kind of makes a triangle there, if you can see that. So let's go ahead and state what the definition of this 6 trig functions are here. And we'll pull up, just go ahead and pull up some graph paper, and I'll go ahead and graph this for you. So let's say my angle, I've got my initial side here, and my terminal side, let's just say we're right there, and the angle is right here, and let's say our point is at 1, 2, 3, 4, negative 4, 1, 2, 3, no, let's go, yeah, let's just go right here. Okay, so that point is at x comma y. Well, the y value is going to be how far we go up there, and the x value is going to be how far to the left we go there. Okay, turns out that the sine of theta is just y over r. So whatever the y value is over what you find for r, and remember r is how far it is from the origin to that point xy. To find the cosine of theta, it is just x over r. To find the tangent of theta, it is y over x. And we'll explain more in the next couple of days why each of these are, but this is how just the definitions of those trig functions. So that makes the cosecant of theta r over y, we just flip it. That makes the secant of theta r over x, and that makes the cotangent of theta be x over y. So there are 6 trig functions. I would make sure you get that written down. We'll kind of have a shortcut in the next couple days, but that is the basics of those 6 trig functions. Okay, so if you got a pause or anything, pause it, come back to it. Alright. So if I'm looking for r, how do I find that? Well, I'm just going to use the Pythagorean theorem. I do r equals the square root of x squared plus y squared, because that does just form a triangle right here where r is there, x and y, x squared plus y squared equals r squared, or r equals the square root of x squared plus y squared. Okay, so if you want to find r, that's what you do. Let's go ahead and do one here. Let 3, negative 4 be a point on the terminal side of an angle in standard position. So we plotted that over here on the graph. Right here is 3, negative 4. Evaluate the 6 trig functions of theta. Well, first thing I have to do is I need to find the value of r. So I'm going to use the Pythagorean theorem and plug those in there. And it turns out I get 5. 3 squared plus 4 squared is square root of 25, which is 5. So r is 5. So now I can write the following. The sine of theta is y over r, or negative 4/5. That makes the cosecant r over y, or negative 5 over 4. I'm just plugging those in, x, y, and r, from right up here. Okay. Cosine x over r, 3/5. Secant r over x, 5/3. Tangent y over x, which is negative 4/3, y is negative, and cotangent x over y, negative 3/4. That was a simple just plugging in what I had, the information I had, right there. Okay? Let's look at another one here. Go ahead, see if you could pause and solve this one maybe on your own. You've got the point negative 12, 5. Negative 12 is your x. 5 is your y. Find r and go ahead and plug those in. So pause, see if you can solve this based on that example we just did. Hopefully you came back here, and when you went ahead and drew this right there, drew that in, you found out that r was 13. 13, because 12 squared plus 5 squared, the square root of 144 plus 25 is the square root of 169, which is 13. So that means x equals negative 12, y equals 5, and r equals 13. So now the sign we said was y over r, so the sign is equal to 5 over 13. The cosine is x over r, which is negative 12 over 13. And the tangent was y over x. I'm just taking those from what I said earlier, which is 5 over 13. And to find the other ones, I just flip it. So the cosecant is 13 over 5. The secant is negative 13 over 12. Notice it still stays negative. And the cotangent of theta is 13 over 5. And there are our answers right there. I think I did one wrong though. I can't have 5 over 13 for both of these. That shouldn't be 13. X turns out is negative 12, so I got to plug that in there. 5 over negative 12 for the tangent, which makes it negative 12 over 5 for the cotangent. My fault there. Okay, so it's just plugging those in to the trig functions we learned. Last thing here is what a reference angle is. So what a reference angle. The values of trig functions of angles greater than 90 or less than theta can be found using corresponding acute angles called reference angles. So reference angles are corresponding acute angles less than 90. Less than 90. Okay? Basically, it's the acute angle read theta primed. So when you hear reference angles, it is theta primed. It is formed by the terminal side of theta and the x-axis. So if I was to draw one here, my regular angle would be like this. There's my regular angle. My theta prime then would be right here with the y-axis. We'll talk about that more tomorrow, but just to get an idea that a reference angle is an acute angle formed by the terminal side and the x-axis is key. Alright, so that is the end of episode 10. We'll do some examples in class tomorrow and then have some time to work and find some reference angles. So be ready to rock and roll.